All right. Good afternoon, everyone. Thank you for joining the session today. I had an idea over lunch. Are you guys all in for a surprise? I was thinking maybe we should change the topic and talk about Copilot. Just pulse check, making sure you guys are all awake. Now, we're going to talk about planning your team's phone journey the right way. Okay? And then for some reason, if you want to plan your team's journey the wrong way, it's actually fairly easy. Just don't do the planning, and you'll be right there. Like every other session, we just want to thank our sponsors to make this event happen. I love this event. I mean, obviously, you all are here for a reason. I find a lot of value out of these sessions, right? And just the networking and stuff like that. So thanks to all the sponsors for making this happen once again. This is the agenda we have today. We're going to talk about, we're going to do a little bit of introduction, talk about why this topic is important, which I had submitted like 3 sessions, but this was the one that was picked, probably for a good reason. We're going to talk about connectivity, just kind of take a step back, see how Microsoft Teams connects, and then we're going to talk about network consideration, which is probably where we are going to spend majority of the time because it's pretty important. And then we're going to talk about some telephony assessment piece, user adoption strategy, and some Q&A. Does that sound good? All right. Introduction. So who am I? My name is Satyendra Sharma. I am a principal collaboration architect with Netrix Global. I did not have time to create a animated AI image like Juan in the keynote, so you're stuck with my couple of year old picture. I have been in the industry for a while, so my career, enterprise career, started with Exchange. So I was an Exchange engineer working on Exchange 2000 onwards till Exchange Online. And then I made the shift to go to real-time collaboration. So my first product was OCS 2007. And then 2007 R2, Link, all the flavors, Skype, and now Teams. So a little bit of experience. I do live in Milwaukee, Wisconsin, so we are super excited about the weather finally turning nice. Can't wait for the summer. And when I'm not working, I do love to spend time with my family. Initially, I had golfing there, but I figured probably should put family first. We do have 2 little kids, so we have a almost 2 years old and a 10-week-old at home. So life is a little chaotic, but it's all fun. We love it. They're awesome. And I have a crazy rescue dog, Marley. She's just crazy. What I do like doing is solving business problem by collaboration. All right, so my job responsibility includes not just Teams. So I am a practice lead for our digital workplace area, which covers UCaaS, which is where Teams is, and CCaaS, contact center, and the meeting solutions. So the combination of all 3 is solving a lot of collaboration problems, because in today's day and age, every customer, every enterprise customer we talk to, they have at least 3, if not more, different products doing redundant things, right? And I think in most cases, thanks to the pandemic, it probably had something to do with it. So my LinkedIn QR, I do have that at the end, so if you want to connect, I would like to connect back with you guys. So the big topic, why do the due diligence, right? You would think it's a no-brainer. Everybody should be doing due diligence, but we see it more than we should, like oftentimes how this gets discounted. So people, they feel like maybe they know what they're doing, or they read a few articles online, they have the confidence, let's go into the deployment, and then boom, we got all kinds of user issues. So, and one of the reasons why we see due diligence is not done properly upfront is because due diligence takes time, and time equals money, right? So if somebody is going to do discovery assessment, either it's internal resources or external consultant or whoever, that's gonna cost money, right? And a lot of the times, maybe it's budget driven or whatnot, it gets discounted. So we're gonna talk about why it's important and why you should invest into it, because the returns is going to be far greater than the initial savings that you will have, right? I have an example to talk about for this. I was involved in this project from the beginning, so I've seen full spectrum of the initial engagement till the final delivery, and this was a large healthcare company, right? We spend a lot of time upfront to do discovery assessment of their current PBX system, which was ancient. Like, people didn't have access to it, nobody knew how things were set up, right? So the more we started, and sometimes some of the discovery, we had to go like reverse engineering, like literally. You go to a wall, there's a phone sitting, and then we trace the cable, see where it goes, and then from there, see what switches connects to, and so on and so forth, right? But the point is, we did our due diligence, we got a good understanding of what we are dealing with, and we solutioned the deployment accordingly, right? Microsoft Teams was the main product, but with all the learnings that we gathered in the discovery, we had to add a few other products to make the whole, solution topology for them. What did that result into? That resulted into, first of all, there was no big surprises when we got into the project, right? Like, nobody came back screaming when we unplugged the switch, like, holy crap, my phone went down, or doorbell is not working, and things like that. So we covered all our bases. And then on the pilot deployment was the other area. So we did our discovery, we did a proper pilot, right? So the pilot is also a topic that we'll talk about a little bit more. We did a proper pilot, is what I call it. And then we got a user acceptance testing. We created all the right material for the users. Communication went out properly. And the result of that was we were able to expedite the migrations, right? Because it was tested, it was proven, it works, we have all the instructions. We were able to expedite the project, and the project was completed 4 months ahead of schedule. And everybody loves that, right? One of the other benefits was we also actually saved some money on it, because there were some devices that people claimed is mission critical, I cannot get rid of it, but turns out you can, right? So we got rid of it, and all the funding that was allocated to buy additional hardware was saved. So just one example I wanted to share with the group over here on why this could be beneficial, right? So those savings in that particular example, from dollar-wise, was a lot more than what was invested upfront in the discovery assessment, right? That make sense? Okay. So I put this together because I'm a visual person, and I think it just makes life easy. What I'm trying to tell here is the story of why doing the discovery of the infrastructure and connectivity, which is the focus of our session today, is important. Because if you look at it, right, so we got infrastructure connectivity, the technology in this session is Microsoft Teams. But technically, it could be anything, right? It's not team-specific stuff, but it could be any product in between. But our end goal is end user experience, right? That's what we are after. We want to make sure that the technology is deployed properly, users are happy, and then they are using it the way we want them to use it. So if there's issue down here in the connectivity and infrastructure, guess what? It's got a direct effect on what the users are going to experience, right? And I have a next slide that kind of talks about a end user perspective, right? So I stole this from Microsoft slide. May look familiar, but it does the trick that I want to talk about, right? So this user over here, Let's give her a name. Let's call her Amy, right? So Amy over here, she's using Microsoft Teams. She's got all the modality turned on. She loves using it. She's able to join meetings. She's able to do audio call. The audio quality is great. She's able to do video. The video works properly. There is no the blur video, right? Or video dropping. Screen sharing is working whenever she wants to. She's happy. She loves the tool. She's productive. She's focused. And that's what we want, right? On the other hand, if things did not work the way we, as the technology leader, want, what the end user is going to focus, right? The calls are not connecting. The meetings are dropping. The video is blurry, right? The screen sharing doesn't work. She's unhappy. She's distracted. Their tool is not doing what she wants. She doesn't want her coworker or her clients to experience this chaos. And I'm sure you all have experienced this. When this happens, what happened, right? The first thing that I have experienced is people will go and sign up their own personal account on some third-party tool, right? That is not a corporate tool. So they may go sign up for Zoom or RingCentral or whatever, right? We don't want that. We want them to use the tool that we have decided on and deployed. So, end user perspective. So I'm going to take a step back and go to the basics, right? And for me, it's helpful, and I think it's helpful for everybody, just to take a step back and see how Teams actually connects. And that will make a lot of sense for the future content that I have for the network consideration side. The Microsoft Global Network, it's the second largest network in the world. And I think that's still true, unless somebody here knows otherwise. Okay, we'll just go with it. It's vast, it's massive, right? They have a lot of private connectivity, dark fiber, across the ocean, across the continent, all over the world. I have that picture from the Azure connectivity website. Have you guys seen that website, the Azure connectivity one? It's got two modes. It's got a map mode and it's got the globe mode. The globe one is super cool. You should go check it out. You'll get all the links in this deck, by the way. So, I have hyperlinked it, but you'll get the link. The globe just turns around. There's all the wires connection running, and there are little floating satellites all over the place. It's kind of fun to watch. So it's massive. It's private owned. It's connected to over 2,700 ISPs. What does that mean, right? So from a connectivity perspective, Microsoft has taken initiative to work with ISPs to do peering, right? And there is a website, I'll add the link before the deck gets shared. I think it's called peeringdb.org. So you can actually literally go there, find the Microsoft network, and you'll see all the ISPs that Microsoft is peered with. And what happens is, let's say, Lumen, right? So if you use a Lumen as your internet provider, if they detect there is a connection on their network that is destined for Microsoft Cloud, with this peering, they can expedite that connection, right? Not in the sense of QoS, but in the sense of hops. So instead of taking a long route, it may take a shorter path just to make sure the connectivity goes to Microsoft as quick as possible. And that's going to be a common theme for this whole session. The main point is given the Microsoft's network, and it's got no jitter, no packet loss, high bandwidth, no packet drops, right? Stuff like that. So we want to make sure we get on their network as fast as possible, right? And then just use Microsoft network for all the internal connectivity and stuff like that. So that's the main core of the message. Internally, there is also some prioritization. So there is a audio traffic that is prioritized on the internal Microsoft network. So another benefit, right? Just get on the network and that you don't have to worry about it. There is an option of express route. We are not going to go too far into it, but express route is essentially a private connectivity for a large enterprise who want to have a point-to-point connection into the Microsoft backbone directly, right? Little fun fact, in case you didn't know. You can go to moon and back 3 times with the amount of cables Microsoft has deployed, in case it pops up in a trivia or something. So now we're going to go deeper, okay? So from a Teams perspective, it is a client that connects to Microsoft. It's got 2 categories, essentially, right? It's got a signaling side of it and a media side of it. And it uses a bunch of protocol and network destination, which is already pre-published, if that's a word, pre-published, in this 365 endpoints URL. I'm sure everybody knows about this. It's a very lengthy and detailed article of Microsoft's public IPs by workload. And inside of workload, there is 3 categories. I think it's allowed, default, and optimized, right? It may be in different order, but the point is they have all their destination IP published in this network. So signaling is essentially your connectivity. It's your registration. That's how you go to Microsoft. You say, hey, I need to sign in, log in, authentication, authorization, so on and so forth. The signaling and the registration happens over TCP port 80 and 443, right? 80 is just a redirect. Nobody really actually uses 80. If you go to 80, it'll redirect to 443. It's a HTTPS-based REST connection. The media is where things get a little interesting, right? So when we talk about media in Teams, there are different types of media, right? 3 categories, to be specific: audio, video, and screen sharing, which screen sharing is also a VBSS, which is video-based protocol, right? But we have it categorized in 3 buckets, essentially. And given what modality you are using, a specific port could be used, right? So by default, everything goes over 3478. But if you go into your tenant and make some configuration changes that we are going to talk about, it can segment the traffic by different ports, which allows us to do a few more things, okay? There is the media prefers to go over UDP. So all those 3478 through 81, those are UDP ports. And UDP is your friend when it comes to media. We always want to we should do UDP. There is a TCP failback in case a UDP is not allowed. The client and the service will negotiate down to TCP, okay? I have some bullet points here. TCP, UDP, in case you don't know, TCP is a stateful protocol. It likes to know where it's going. It does acknowledgement every time a packet is received by the recipient. So there is a transaction, right? Like every packet is known and it is acknowledged when it's received. If a packet is missing and there is no acknowledgement for it, it gets retransmitted, right? And if it gets retransmitted, the rest of the packets behind it gets delayed, right? Which, if you can relate it, right? We don't want that for audio video traffic. And UDP is stateless, yeah. So there is no acknowledgement, fire and forget. There are other terms which may not be conference appropriate, but the fire and forget works best, right? So you just shoot it on the network, it'll get there where it get there. If there are a couple of packets lost, it's generally not a big deal, right? So if a few packets here and there, no issues with it. So we want UDP anywhere possible. So with that in mind, now, there was one more thing on that Microsoft Global Network page, the entry point, bullet point, right? So if I can go back, I suppose. Where is it? Oh, edge location, yeah. Keeps changing a name on me. But so edge locations are essentially a front door. It's called edge location. It's also called, front door service. It's called entry point, whatever. But the point is, these are your connectivity destination. You can go connect to it, and Microsoft has lots of them, right? And these are location specific. So if I'm connecting from Chicago, my entry point most likely will be in Chicago if all my infrastructure is set up properly to let me go out Chicago, right? So that way we try to keep connection local. You all connect to the local egress entry point, and then you jump on the Microsoft network quickly. So when we fire up a Teams client, what actually happens, right? So Teams clients are coded to go do a discovery for specific URLs and IPs, right? So for example, teams.microsoft.com, you fire up Teams client, it'll go to your DNS server, be like, hey, I want to go to teams.microsoft.com, give me an IP address. Your DNS server will have a forward, like, hey, let me go check with the public DNS. You find the IP published on the public DNS, and then it's returned to the endpoint. The endpoint will go and try to connect to that IP, right? So that's kind of like the typical DNS resolution. Now what happens is when the connection goes to the Microsoft cloud, that's where the Anycast kicks in, right? And we're just going to call it Anycast magic, because I don't want to go into the details. So it looks at your source IP address, right? So anytime you leave your network perimeter, you get assigned with a public IP. You can go on your PC and do what's my IP on Google, and you'll see what your public IP is. So Microsoft Cloud sees your public IP, and those public IPs are associated with a location. And they're like, okay, this guy is connecting from Seattle. Let me send it to the Seattle front door service. And that's where the connection goes. And that's how they kind of keep it local, right? Not prove it, but just because I like to go under the covers a little bit and see what's happening, right? So I have a screenshot of the Wireshark for their DNS query that my client made, right? That's the top one, teams.microsoft.com. I got 2 IP addresses, but when I look on my PC, I can I'm doing a netstat just to kind of focus in on my Teams process ID. So you can go to your task manager, find the process ID for Teams, do a netstat, and then you see the IP addresses are different, right? So it just kind of tells you that what you get from DNS is not always where the connection goes, right? It could be a load balancer, but most likely this Anycast redirecting your traffic. Everything good so far? Questions? No? Okay. So now that we are connected, now we're going to talk about media, the exciting stuff. So the media happens in a few different scenarios, right? And we're going to go it one by one. So first of all, signaling will always go to Microsoft Cloud, right? No matter what you do. Your client is always going to talk to Microsoft Service. That's your signaling, authentication, so on and so forth. Then we do Teams meetings. So now we are talking media, right? Like those solid blue lines. So in the meeting scenario, all the audio, video, screen sharing feed gets sent to Microsoft Cloud. Microsoft Cloud does its mixing, and then the stream goes back out to all the clients who are participants in the meeting, right? That's how meeting works. Then we talk about one-to-one call. Everybody does it, right? So if 2 Teams users are in the office on the same network, they're gonna do the media directly between their private IPs, right? And there are always scenarios where that is not possible, because I could be working from a different office, or maybe my coworker is working from home, right? I cannot establish that direct private IP connection. In that case, we get our friend over there, Transport Relay, engaged. And Transport Relay is essentially a facilitator for connecting the media between 2 endpoints, right? Because they both can reach Transport Relay in Microsoft Cloud, and everybody sends the media there, and it kind of facilitates the connectivity. This video is amazing. Like, everybody need to watch this video. It's a level 400 video. I think it was published in like 2019 Ignite. It's older, but I mean, that's the best content I could find. It goes through the whole ICE, stun, turn protocol and the SDP negotiations. I mean, these are all under the hood things, but essentially anytime, just to kind of summarize it in a short statement, anytime a Teams makes a call, it goes through this process of stun, turn, and SDP negotiation, right? It's SDP, session description protocol. Essentially, this endpoint gives all the IPs and ports that it can connect on to the other endpoint or Microsoft service. Like, hey, here's all my connections that I can connect from IP ports, and then the other person does the same thing, and then do the negotiation, and they settle on something that works for both parties, right? And it always starts, and there's a priority order for each pair. In every case, the preferred method is to do direct point-to-point wherever possible. But if not, then it escalates and eventually they agree on something. So definitely check that out when you guys get the content. So now we are going to talk about what can we do to make our network better to connect with Microsoft Teams. So here's your traditional network, right? You have your corporate network side, fully managed, full control. It's inside your perimeter. And then we have this thing called internet that everybody's available on, right? So we got corporate network, we got internet provided by ISP, and then we have the Microsoft's giant network. Typically this is how these components are involved, and these components will be involved no matter what. What we can do to optimize this is try to get on the Microsoft network as fast as possible, right? You're not going to get rid of your corporate network, right? But what we can do is make sure your sites, your locations, your endpoints are provisioned so that it's going down local internet egress, right? So surprisingly, we still run into a situation where people have the old hub and spoke topology, right? Like all these branch offices are connecting to their headquarters or mothership to go out to the internet. Doesn't really work for CCAS or SaaS, I should say. So try to make it as quick as possible. One of the friction that I hear from customers is that I don't want to compromise my corporate network. I don't want to do this. If I do like local internet egress, I don't know what's happening and things like that. One of the core thing, and this is beyond Teams, is just cloud in general, right? Those cloud environments are not in your data center, and people just need to get to terms with it. It's in the cloud, right? The security topology also changes with that, right? You can lock down your firewalls if you have everything inside your data centers. But since it's not, we need to shift that security from network parameter to endpoints, to connectivity, to data. Like that's where the security is shifting, right? There's plenty of sessions in this event here that talks about security, the defender, all this stuff you can do. So that's what people need to do, focus on, instead of the network people like, oh no, I'm not going to allow local internet traffic. So anyway, we can talk about that forever. There are some performance guidelines, right? So this table, if you have not seen, has been out there for a long time. There are some performance measures that we need to meet, right? Most of them are self-explanatory, right? Around trip latency, how long it takes for a packet to travel, back and forth. Packet loss is how much packet loss can we sustain, and then packet reorder, jitter, stuff like that. And each one of these things have a direct impact to what happens to your audio-video connectivity, right? And that's just the nature of how Teams work. Nobody's going to complain if your email arrives 2 minutes late, right? But if your audio is disconnected for 2 minutes or your video is disconnected for 2 minutes, That's a pretty big deal, right? Nobody's going to want to deal with that. So, and there is a way we can measure how your network compares to these things, right? How can we do that? Anybody? No? By testing your network. So you can test your network. Anybody know about this tool, the network assessment? Yeah? I love this tool. It's probably one of my favorite. This tool is a free tool published by Microsoft. You can go and download from that link once you get the material, or you can search. What it does, it will do a TCP/UDP check connectivity with Microsoft Teams service, right? It purely does a quality check, right? So like anytime you bring up a network testing tool, the network people start to freak out, like, oh my God, he's gonna take my network down. That is not the case. This is not a load test. This is a quality test, right? It's not like the old Exchange load gen tool and things like that. So this purely does connectivity check and quality check. And the way it does that is by playing a small media stream every 5 to 10 second interval, right? So it's like a 5-minute audio file that plays back and forth, and then upon reception of that data back, it will measure on these things, which are critical for us, right? So pretty nice tool. I suggest everybody to run it. And you can run this on, if you have Teams Phone deployed, you can still run it, right? Like there is no harm, it's not gonna affect anything. And you just pick up a Windows PC, load this tool up, and I actually recommend to run this for 7 days. Why? Because you may have stuff happening on Tuesday afternoon that could saturate network, like we don't know. So I suggest to run it for 7 days, get a full picture of your network for a week, and that gives you enough data to give you the confidence that, okay, we are gonna be fine. So here's some examples of this tool, right? So load this up, command prompt, execute the exe under the folder. I've got the help switch over there. So there's a few things it does. So if you don't add any switch, it will do the connectivity check, which is just TCP/UDP port availability with Microsoft service. There is a specific quality check tool that does that audio file back and forth, right? So that's what it does. The web check it does the same thing, but from a web client perspective. So it uses some web browser component and web sockets and so on and so forth. The interfaces will show all the interfaces on the PC. The location will show all your latitude, longitude of your PC where you're running the test from. The second example here is so I just kind of executed the connectivity test, and there are a few things to observe, right? So it is using the source port of 50,000 to 50,019. And that also happens to be your audio port range, right? So Microsoft Teams client uses a sequence of 20 ports for audio, and then 50,020 to 39 is video, and then the next 20 port is for screen sharing, right? So by default, the tool is set to use. There is a configuration file that we can do a lot of things into. I have some screenshots for that. But the top section down here, it's doing the TCP/UDP check, right? So it's trying to connect the 3478 is your UDP control port for turn negotiation, and then it's got the 443. So if they have to do like a media on 443 and stuff like that, it can do that. But the second section is the actual relay instance, right? It kind of says that here too. This is the load balancer, and this is the actual relay instance that would be your media would be transmitting to. So what we want to see is that if it is reachable, the pointer thing doesn't work. Anyway, what we want to see is UDP availability on 3478, 79, 80, and 81. So that's what we want to see from a connectivity perspective. The next slide I have is for quality check. So now we have seen connectivity is fine. Let's run the quality check and see how that works out. So it tells you, right? So when you run the quality check, it tells you it's going to do the 300-second, roughly 5-second interval. I mean, that fluctuates from 5 to 10 seconds, but the point is it happens like one after the other. And what we want to see is those key metrics, right? Packet loss, latency, jitter, and what protocol it's using, more importantly. We want it to be using UDP, and then all those numbers be under the threshold of that performance thing, right? So this one is everything under control. Everything is using UDP. This is a good test result. And yeah, my tip over there that I already mentioned. Yes?
How do you run it for 7 days? What happens on patch 2?
I'll exclude that computer from patching. No, so that you will have to do that anyway, right? Like you don't want it to go through. So a few things to do. In a config file, you update the test duration to be 7 days. That's what the tool looks at, right? The other thing you want to do is make sure that PC does not go in hibernation or sleep, right? So those sort of things. Just make sure the PC is available for 7 days. But yeah, other than that, it should be fine. Yes? Yep, it's coming up. Yep. Yeah, you're not gonna be reading 7 days of text, I don't think. Yeah. No, man, there it is. No more C word. All right. No, good question. Yeah, it's coming because it does generate a ton of data, right? Which is good. Data is always good. The more data we have, the better we know what's happening, and we can make the best decision from it. For comparison, right, I just added a fail test result. I mean, the only thing difference here is it's using TCP protocol, right? And in this case, I went in my home firewall, disabled UDP for testing, and it actually shows, right, it's using TCP. The results are generated in a CSV file, right? So this file can get pretty large depending on how long you run the test for. But yeah, it's all under the local app data folder. So once you have the CSV file, you can do a ton of things with CSV, right? I think over here I'm using Power BI to kind of like just visualize the data, right? And you can do in spreadsheet or anything you want to do, right? But I think Power BI does a pretty good job. So in this example, right, I think I only ran it for a few days. This is an older file. But what I like to do is take the data and put a little synopsis with it, right? Compare it against what the benchmarks are and how does this result come out, right? Clearly, we have some issues here, right? And it does this average and max separation, which is kind of cool. But you can literally see in the data how many times it's maxing out. If it is constantly hitting, what is that? Like 50-some% packet loss? Yeah, that's the bad news. We don't want that, right? So for us, as Teams people, we can take this data, go to your networking people, and be like, hey, look, we got some problems to fix, right? So it just makes your conversation so much easier versus just giving them the link to the Microsoft IP URL and be like, just open all these ports. And those are not small subnets. They're pretty large subnets, right? So always back everything you do with data. The other thing that I have right there, make sure to test your wireless network. That is something that often get overlooked. It's amazing how many people are switching to wireless type work situation, right? I work for a client in Wisconsin. They opened a brand new building downtown Milwaukee. It's like this beautiful glass building. And then one of the leaders had a great idea of making the whole building 70% wireless. So even if you're at your desk, they wanted to have like a wireless experience. People move around. They had this pretty fancy like collaboration bar area that people can like eat lunches, take their laptops and stuff like that. So it definitely plays into the whole experience, right? So make sure you test your wireless stuff, do it for 7 days, and then run it again, right? If you know there is a network changes happening or a new site is getting added, run it, right? Same thing, it's not gonna hurt your network or take anything down. So just run as many times as you want. Some of the config things, right? So this is kind of what we talked about. The top one is, you'll probably never do it, but if you wish to target the test to a specific relay instance or a relay IP, you can feed that into the config file. You can control if you want to enable TCP testing or not. So those things. What are your ports? Typically, you would leave that alone, right? But if you wanted to test it on a specific QoS port, you can modify that. And then the source port range. So if you could literally run the test as an audio test and then change the port to the next 20, and there'll be a video test, and then another one for sharing test. But generally, if the audio is open, more than likely the rest should be fine, but you have that option. And then the duration is where you would change to 7 days, whatever that translates to. So there is a lot more you can do. It's in the same installer directory, so go check it out, the config file. There is this other tool. It's like a web-based connectivity tool. So you will have scenarios where you won't have the luxury to run the test for 7 days and analyze the CSV and so on and so forth. This is more of like an ad hoc test. You can go to connectivity.office.com and it'll show you all the closest entry points, right? And what location you are, what's your ISP, and where you will be connected to. So just something real quick on the PC, in the browser, you can run it. There is a exe that gets downloaded with it that does some additional checks. If you have the installer permissions, so you can download it, and that'll do those other tests in terms of media connectivity and things like that. I think it's good to do like ad hoc testing. It doesn't give you the data of IP, ports, protocols, stuff like that, which is what the core is, right? But I just wanted to include this for you guys. Oh man, I'm gonna have to expedite some stuff. So Network Planner, have you all used it? Anybody? It's a tool. It's in the admin center, so it's in your TAC down below on the right side. It does help with projecting bandwidth on your network, right? So if Teams is brand new, you don't know how much load it could potentially add, this is a good way to just get some sense of what this would look like. So to start with, you create a plan, and this is like your topology, right? So I've got a CV and LLC for this event, and then I have 3 offices, and you can define how many users, what kind of internet breakout, and what is your PSTN connectivity, right? So you have direct routing, calling plan, and operator connect in there available now. And it also has an option to use other locations' internet egress, right? So like I talked about the hub and spoke. So if you have that, you can run it, and it'll project your WAN bandwidth projections. So you create the topology. Next thing you do is create personas. And this thing is improved a lot. I think last time I looked at it, it only had like audio, video, screen sharing. But now you have these additional options, so you can really fine tune on what capability you are planning to deploy and align this tool to it, right? You can modify existing personas. You can create 3 additional personas, which should be sufficient in most cases. But once you have your plan, your personas, you create your network sites, which is all your office locations. One thing I called out is like if you don't have the address in the site, it shows like as an incomplete for some reason. So you can throw in an address. I'm just using a Starbucks address because they're everywhere. But you can also add network subnets, which is not really needed for it. But if you want to like go all the way in and put everything, you can. And then you allocate users to the personas that you defined by each site. The key here is the remaining user must be 0. So if there are any leftover users, the run button will not be available for you. So make sure you allocate all the users to the right personas. The remaining users are 0. There is a bandwidth allocation section. So if you have any queuing or prioritization of traffic on your network, put that percentage and then run the tool. It generates pretty good data. I think it's got 2 flavors of report. So whatever your preference is, I think I like the top right one. But you can see, based on the information we've fed in this tool, we've got some problems, right? Like the first thing from Milwaukee office is it's overloading your WAN because it does not have a local internet egress, right? So that should be a pretty easy fix, right? Internet is cheap. Just buy one for their office, buy 2 for redundancy, and you should be good. So there is a link for the Microsoft published bandwidth requirements. The one thing that this tool unfortunately doesn't give access to is what protocol it's using, right? What codec it's using, how many calls it's making, things like that. So it's got some internal logic that it's using to just simulate this traffic. But nonetheless, we have something to kind of prepare for your network. The next section is a VPN. Anybody here has a VPN? Yes?
I have a question. Had complaints from some of our larger and I think we told by Microsoft that once a meeting gets above a certain level of users, it's a multicast stream or that
For a regular Teams meeting or the live event?
Teams meeting, they have their
Yeah, I mean, I think they all receive their independent feed. I mean, the only scenario where you would have that kind of branching off, I think, would be the live event or webinar type situation. But that's all TCP too. I don't believe so. Yeah, I don't believe so. Not to my knowledge, at least. Like, I think it's independent. The other thing is, since you brought that up, so whenever you do the webinars or town halls and things like that in Teams, those are, for the most part, is like one-to-many, right? Like people are just receiving a traffic, and those are all TCP. So there is no UDP option, just FYI. So we're gonna kind of talk about some VPN stuff. You guys here use VPN for remote users? Yeah? Do you have split VPN in place? Have you tested it? Are you sure? Okay, all right. Okay. Sure, yeah. Okay.
You gotta wait for them to fix it.
Yeah, so good. Yeah, if you have VPN scenario, definitely take the time to do split VPN because this is gonna save a lot of pain with remote users, right? VPN tunnel, I think we all know what that is, secure communication. There are different flavors of it, so you can force everything to go down the tunnel. It's an already encrypted tunnel, then you're shoving Microsoft traffic on top of it, dual encryption, UDP over TCP, not a good situation, right? So, luckily, we have a lot more information about split VPN. So those article things on the top right there on how-to guides, none of that existed when I first did split VPN. And that was with OCS 2007 R2. It was not a good situation. But now, most of the vendors have either a built-in configuration in their product or have a pretty good configuration note to do it, right? In a nutshell, what we do is we instruct the client where the VPN client is connecting from, push a bunch of routes to that endpoint saying that if you are trying to connect to any of these Microsoft IPs, use your local gateway. Do not come over the VPN tunnel, right? That's essentially the gist of it. There is a scenario where you can, primarily for media, right? We want the media to go out locally. You can send your authentication authorization through your tunnel that's typically fine because it's lightweight traffic. And especially if you have conditional access, VPN is your known subnet, right? So if you have a subnet-based conditional access, if you push out the authentication authorization out local, Teams is not gonna accept that connection, right? Because it's an unknown situation. So you could send the authentication through tunnel or push everything out, but adjust your conditional access accordingly, and test it. You can do traceroute, you can do the network assessment test, and it'll kind of show you what IP is using to connect. The DNS resolution is optional. It's not really needed unless you're pushing out the registration traffic, right? The media always happens over IPs, so there is no DNS needed there. Optionally, you can block it. You can take it next level and be like, I want everything to go out local gateway, and as a safety mechanism, I will put a blocker on my VPN tunnel so it does not come over my tunnel, right? If your configurations are done exactly properly, that'd be fine. But if the local gateway is unavailable and the client tries to go over the VPN and there's a blocker in place, the users are gonna see that, right? So yeah, this one just shows what that looks like. We just kind of talk through all this stuff. So I'm gonna skip over this quick because the next one I have is QoS. So we're gonna try to wrap this up and see how far we go. Anybody here has QoS deployed for Teams? Yeah? Have you tested it? Maybe, yes, no? Okay. What is QoS, right? QoS is just a priority mechanism to prioritize the traffic on your network. The easiest example I like to use to describe this is, think of it like a highway, and those QoS traffic is like your carpool lanes, right? So you just kind of take the traffic, goes down the carpool lane, it travels faster on the network, right? It's all done using DHCP, not DHCP, DSCP for tagging. And there's two ways we can implement it. You can implement it on your network side based on the ports and IPs that we know, right? Teams uses specific ports for audio, video, and sharing. So audio you can prioritize, and then videos you can put in like different buckets. Or you can do it client-based. So let the client take the traffic with the appropriate DSCP value, and your network devices will look at it and then put it in the right queue automatically, right? So in the tenant, you'll have to enable the QoS that will force the client to use these 20 port ranges, right? So that's how you create your policies as the source port. Then for Windows PC, you can create a Windows GPO and then apply it to the users. And then it's actually also based on the application name. So make sure you have the right application, because that exe has changed, right? It used to be Teams, the classic one, but now it's MS Teams. Go ahead.
Does the WebRTC version of Teams in the web use the same ports and protocols as the exe?
No, I don't believe so, no. Correct. Yes. Yep.
So there is no QoS.
I don't believe so, but let me look at that quick. I may have to kind of check on that, because there is that connectivity test for the web. So I haven't looked into that. Like they could be using the same ports, using under the WebSocket or something. So we can find that out for you.
I'll ask it.
Yeah. Oh yeah. Ask Seth that question. That's perfect. But yeah, I mean, so Windows policy obviously applies to Windows, but there is also Intune option now. If you have not played with it, test it. I mean, that applies to a lot more endpoints, right? Your Windows, Macs, stuff like that. It's the same situation, right? You just gonna create the application, source port, DSCP value for each modality, and just apply it to a group, and then everybody in that group inherits that policy, and then traffic is tagged. You can validate it using a packet capture. So if you take a Wireshark or Netmon or whatever your favorite tool is, you can see in the header the DSCP value of 46 associated with the Microsoft destination IP and the source port, right? So that's how we can confirm. The the one main thing with QoS is make sure it's done on all your network links. Like, don't do it like on one side and not on the other side. You can even do it on the return traffic from your edge network coming back in if you really want it. However, my comment here at the end is managing QoS can be expensive, right? Like, you have to manage multiple places, make sure your networks are up to date with it. Instead of that, fix your WAN, what is happening, right? The QoS will only kick in if there is congestion on your network, right? And if you're dealing with congestions, most likely you have bigger problems to solve, right? So, yeah. But if you do deploy QoS, there's ways to test it. Yes?
So, do most internet service providers honor
No.
ISP tags? And so once you're hitting the internet,
Mm-hmm. Exactly. Yep. Yep. It's all your internal managed network. There is no QoS unless you do express route or something. Yeah. So, yeah, if you have internal congestions, do QoS. Use the ISP. You can validate the ISP if they're doing the ISP peering, and then get on the Microsoft network as fast as possible. So try to minimize corporate. Internet we cannot get rid of, unfortunately, so we just have to use it and then get on the Microsoft. This is just a summary of what we talked about. The local DNS resolution is the other thing that we need to be mindful of, especially for satellite offices. Make sure they're using local DNS if you have an instance, or use some sort of public DNS and stuff like that. Bypass proxies, inspections, pretty hot topic with security folks, but I think there is enough documentation to back that up. So please share that. There are some things to validate on Wi-Fi, right? Coverage, heat map. So whatever vendor you're using, generally there is an option to upload your floor plan and position all your APs to see what your heat maps are, if you have enough coverage and stuff like that. Band steering is the other thing. I think a lot of people do it by default, but if you're not, can I look into that? The roaming aggressiveness, anybody knows what that option is? It's on the Wi-Fi adapter on the PCs, right? Like, I had to deal with that a couple of times because people are on the calls, they're walking around, they're bouncing between APs. So like, you may want to fine tune it. We don't want it to be super aggressive or super not aggressive, right? It's like, so. I got a couple of other slides, but I know we are nearing end. These are just some recommendations on, from a due diligence perspective. Take some time, see what you have, right, from your current phone systems. Look at your carriers, what workloads are deployed. It's amazing how many customers do not have any emergency calling when we get into like migration discussions. They're completely not compliant, right? So if you have anything like third-party, Red Sky, Intrado, whatever, how does that work? So we can translate that into Teams, usage data, your inventory for porting, stuff like that. Because a lot of the time, especially when you deal with older systems, people change. These are 20, 30-year-old systems. The person who deployed is retired in Hawaii or somewhere hanging out, right? So we just want to make sure we do our due diligence. And devices and integrations is a big one. We have algo over here, right? Like, that comes up almost everywhere. Your paging systems, your doorbells. I have clients who have hangars at the airports, and those are running on ancient analog systems, right? Like, how do you interoperate that with Teams? Our favorite faxes, get rid of them, right? Or if there is any business continuity, right? Like, if you have redundancy today, talk about it, right? Because if you go to Teams, and if there is we're just going to call it event in Microsoft, what are the options, right? If you're planning on it, plan it from the beginning to have a backup systems or whatever the case may be. If you are not, it may be just a documentation portion, right? That you did your due diligence, it came up, we decided collectively that there will be no backup system with Teams, and that's your CYA. Migration planning is, just gather requirements if there is any, right? Like, obviously, user change, their need change, things like that. do pilot, collect pilot feedback, and then communicate migrations properly. From a pilot perspective, please do a true pilot. Don't test calling plan and go deploy direct routing, because that's apple and orange, right? So test what you're planning to deploy in production, in pilot, if possible. User adoption stuff, obviously a pretty critical component to make sure our users are ready for the change that's about to hit them. There is a pretty good documentation repository. If you haven't seen it, again, you'll get the links for this, or you can look it up. It's pretty easy to find. Those content, you can rebrand it, right? So a lot of them stick your logo, make your edits, whatever. If you have your internal communication team, make them kind of do all that and make sure it's communicated. Sometimes it's almost better to over-communicate, right? Because we don't want people to come back and like, oh, I didn't know I could call forward from Teams to my mobile numbers. Like, nobody does it, but again, we just want to make sure they have. And again, depending on the company you're working with, champions, that works out pretty good, right? Kind of offload some of the support responsibility to tech-savvy people within the user community, and then just recognize them, right? Because a little bit of recognition will boost them more to do local support, right? i.e. increasing the adoption. And then if you have any success stories, yeah, we did this for a few customers. So in reality, you cannot please everybody, right? That's just the nature of human. So if you have a department or a team that is very happy with the team solution, and they write something or you interview them, throw it on your internal website, right? SharePoint, whatever, just like blast it out so people are like, oh, what am I missing? What am I doing wrong? And that will cause the curiosity for them to go and make sure they're using the tool properly. So I know we are over time. I just have one main bullet point from a summary perspective. Just do your due diligence. That's going to save you a lot of pain in the long run. Any questions? That is my crazy dog, by the way. Yes?
I just read about recently where some of these guys are using the secure global client or whatever it's called, and there's a Microsoft 365 traffic routing tool in there, and they were suggesting that would improve your latency to Microsoft's environment, basically taking more front door access to that global secure client than the team native experience. Do you think that's true?
I mean, my knee-jerk reaction is it's not, but I would defer to the vendor and their documentation, right?
Yeah, this is the Microsoft piece, right? The Zero Trust, what's it called, right? Global secure client.
It's not the Azure VPN, is it?
Like inside Entra Global Protect or.
I mean, you can easily test it too, right? So if you do it, like do a pilot, just do their testing, so your traffic is routing. Most likely, if it is a Microsoft component, maybe they have some of this rule built into it, but I would just do your validation on top of it. Yeah. Should be pretty easy to do. And even if you use it, instead of running the network assessment testing, you can even go to your CDR records, your call analytics, and go into the advanced and debug section. It'll tell you exactly what IP ports and protocol was used for that call, right? So you should be able to do that fairly easily. Yes, Gary.
Pertaining to the voice traffic and your extensive network testing, do you have any comments, good or bad, about the robustness of the voice protocols and their network needs?
Yeah, I mean, that could be a whole session in itself when we talk about codecs, right? I mean, I will tell you one thing, compared to OCS, to where Teams is right now, it's night and day, right? Or we have so something that happens with the SDP negotiation when they share the IP ports, there is also negotiation on bandwidth and protocol. So they have different protocol, and now I think the official term is adaptive bandwidth, so it can scale up and down. Like, I don't know if you've experienced, but if you are on a video call, sometimes your video will be shut down just to maintain audio, right? So not only they have adaptive bandwidth by workload, they have adaptive workload, I guess, in a sequence. But yeah, there's a whole bunch of other stuff we can talk about.
And that's going to get that real quick. I mean, I understand there's a level of robustness there that didn't exist in the past around compression, around shutting down video, and things that we've done automatically on the back end to sort of negate some of the network quality, latency, drop packets issues.
Right.
That's kind of been my experience. I was just curious if you thought the same thing or not.
I mean, honestly, I've not. And, in most of my cases, like when we run through this due diligence thing, the bandwidth, I mean, there is some controls you can do in the Teams meeting policies. Like you can control the bit rate on like what bandwidth you want to allow and stuff like that. But that's just, most of the time, it's not really necessary if your network is able to handle. Yeah. All right, I think we're out of time. Thank you for joining, and